Let's go derive the formula for the angle between vectors. Apologies on the last video for a little sound glitch for about 30 seconds, but I ain't got time to go back and do it again. On we go. So let's see what's got. Our dot product, yeah, we got that down. We got it dialed by now. Now, what are we going to use this dot product for? And really, for right now, it's for finding the angle between vectors. At least for your world right now, you're thinking dot product goes along with angles. It's how it helps us to find angles. So I'm going to do the derivation here, and some point in time, I'll stop and I'll get you your quiz. There's one problem, and it's just I'm going to ask you to find the angle between two vectors. And you probably want to watch the subsequent, the video after, whatever that one is. English, math. Okay, we want to find the angle between two vectors. We're going to use the dot product to do it, and we're going to use our knowledge of triangles. So you're going to have to give me a little bit of suspension of disbelief here. I would typically show you in a class, but I don't really got the time for it. So I'm going to create a vector that's going to connect these two to make a triangle. So if we put the vector and we head in this direction here towards the tip of V, we can actually call this vector V minus vector W. Again, I would do it in class for you. I would show you why. We'd move things around and show you that they don't have to start at the same spot or end at the same spot. As long as it's pointing in the right direction, it has the same length, and you scoot it around, and this becomes the case. Just take it or leave it. You can go and prove it to yourself if you like. So now we're trying to find that angle in the center. That's the game, the angle between those two vectors. And also an angle between two vectors can never be larger than 180 degrees, right? Or else we'd be looking at the other side of it. So we're just looking, but it can be larger than 90, smaller than 90, shit like that. But we look, this is not a right triangle. So if it's not a right triangle, we're either thinking law of sines or law of cosines. Let me tell you, you don't use law of sines for pretty much shit except for solving triangles. So maybe we should look at this thing as a law of cosines to try and solve for that angle. The problem is we don't have any lengths written down there. We have the vectors describing what they are. But in order for us to have any sort of lengths, we need to call them the magnitudes. Now the magnitude of vector W, we could call it like 6. All right, it's a number, and then we can look at the magnitude of vector V and the length of it. Maybe that's 14 root 3 or some shit. And now we're going to slap the magnitude around our vector V minus vector W. Of course, you remember the law of cosines. We just did this. Let's go get it. Here comes our derivation. So we're going to set this thing up, but let's kind of do one of these. Let's call this like an A. We can call this one like a B. We can call our vector V minus vector W magnitude C. And, like the angle in between, like that big C. So when we go and look at our law of cosines, kind of got it set up for you. C squared is equal to A squared plus B squared minus 2AB cosine of C. Right? When the side is opposite the angle, you always go with that on the side of the angle, opposite on the, okay? Cool. Now let's start replacing things in with what they are. So instead of writing in C, we're going to write in vector V minus vector W's magnitude. And this is going to get long and gross and, yeah, okay, we're going to make it through. We're going to square that thing up, and we're going to set that thing equal to the A squared. And that's the magnitude of vector W squared. And then we're going to add that to, we're going to need to get the magnitude of vector V, there it is, vector V squared. And then we have minus 2 times, and that's, we got to multiply the magnitudes together, or A times B. This is vector V, my bad. Times cosine of what we're looking for, and there's that theta. Bang, so now we want to go through and get it. So here comes the algebra. Woo! And we're going to use some theories of the dot product. Like, we learned something about this. That the magnitude squared, isn't that just equal to the dot product? Isn't that just, come on, it is. So really what this is, no more color coding for you, vector V minus vector W. We're going to take this and we're going to dot it with vector V minus vector W. Oops. And again, our vector w all squared, that's just the same thing as vector w dotted with vector w. Our vector v all squared, that's just going to be the same thing as, you guessed it, vector v dotted with vector v. Minus 2 times, and then we'll leave all this shit alone, but no more color coding. Oh, why did I do it again? I did. Come on. I said I wouldn't. Look how many lines we're writing here. This is ridiculous. Ridiculous. I'll put theta. Well, what we're going to need to do is, we can't mess around with the right-hand side, but into our identity, so I'm just going to yank you back up for just a second. We learned all this bullshit. I said, don't worry about 3 and 5. Don't worry about 3 and 5. I got to worry about 3 and 5. What 3 does, this allows us to use the distributive property to let the u go into the w, or hit the v in the w. And also with 5 in combination of how we can use our constant. So this is what we're going to use this for down here. This is saying that we could essentially distribute right through here. We could distribute, and like FOIL. So let's do it. Oh shoot, what did I just do? Just jumped out of here. Uh-oh. One of these days I'll learn how to edit, but until then, you're welcome. Where the hell did everything go? Am I losing my mind? Oh, there it is. Thanks for bearing with me, huh? So let's go and distribute all this shit through and see what we end up with. So we're going to get vector v dotted with vector v. The next one, we're going to get vector v dotted with vector w, and then we're going to get another one. So that's actually going to be negative 2 of them. Let me get some more room there, right? Hopefully you remember your foiling, and then that's going to be plus vector w dotted with vector w. Is equal to plus da 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 da. Wow, a lot of writing. I'm going to get carpal tunnel here, huh? Whew, go sign up. Theta. Bang! Now the best part. This thing's finally going to go away. And here's the best part. Here's your quiz. So your quiz. Here it is. I just want you to find the angle between. Find the angle between. I'm going to erase this in a second. Vector v, which is equal to, and yeah, you're welcome for these horrible fractions. 1/7. Negative 1/7, comma, 2/9, and vector w is going to equal 3/4, comma, 1/10. So there it is. Your little hidden quiz here is find the angle between the two vectors, vector v, which is negative 1/7, comma, 2/9, and vector w, which is 3/4, comma, 1/10. Well, there's your quiz. Once, twice, 3 times. Done. And back to it. All right, so we go back, where's our equal sign? We see that our equal sign is right there. So let's see if we can't find anything on both sides that match and cancel that out. Look at these v dotted with v's. W vectors dotted with W vectors on both sides. Shit, what is left over? I think we have negative 2 vector v's dotted with vector W is equal to negative 2 magnitudes of vector W times the magnitude of vector V times cosine of theta. Remember, the magnitudes are just numbers. They're just constants going along for the ride. You know what? Let's do the same thing we did before. Let's cancel out those negative 2's. And what are we left with? It's vector v dotted with vector w is equal to the magnitude of vector w times the magnitude of vector v, or turn it around. Remember, it's commutative. And cosine of theta. We're trying to get theta, so why don't we divide out? Why don't we divide out these numbers that are right here? Just these little numbers to both sides. So we're going to end up having the vector v dotted with vector w over the magnitude of vector v times the magnitude of vector w is equal to cosine of theta. And this is what you will find in a textbook as to how to find the angle between two vectors. I've always been curious to know why they don't hit the thing with an inverse and just state it in this manner. That theta is equal to cosine inverse of vector v dotted with vector w over the magnitude of vector v times the magnitude of vector w. They're both valid because cosine of theta, or cosine inverse, understands angles from 0 up to 180 degrees. And that's as large as any sort of vector could ever give you. It could never be larger than that. So what would be the issue? I can't see where there's a domain restriction or any sort of problem. Provided, vector v and vector w couldn't be 0, or else this isn't going to work. But there is our derivation. And now we're going to use these to go through and solve. Because see, here's what we get from the book. We're going to start using this right here to solve some of them, and we'll start messing with orthogonality as well. See you in the next one.